Good morning, guys. Am I audible to all of you?
Morning, sir. Yes.
Good morning.
Okay.
Yes, sir.
Okay. So in our yesterday session, we have started our non-generic collections, right? As part of that session, we have discussed two non-generic collection classes, that is array list and a hashtable. And we discussed that array list basically it is going to store different types of data items, right? You can store any type of values, and the reason is this is working on object data, right? As you know, when a data type, I mean, when we declare something as object data type, then we can store any type of values, and the reason for this is object is the superclass of all .NET classes, whether it is a primitive data type, whether it is a user-defined data types, right? That is directly or indirectly is inherited from the object data type, right? And the problem with the object data type is it is loosely typed in the sense it can store any type of a data. Then if it is going to store any type of data, then what is the problem? The problem is suppose you are storing some, you want to create one integer collection. You use the array list, right? But sometime instead of an integer, you are storing some string value. So at runtime, when you are trying to retrieve the data, you might get some kind of a exception, right? And the second thing is that as it is operate on object data type, right? Then unboxing and unboxing will come into the picture. If you are trying to store a value type, right, integer data, then that integer will be converted into object, and that object is going to be stored. And the same thing is going to be happen while you are retrieving the data. If you are trying to retrieving the data, then that object will be converted into integer and then it will be complete, right? So boxing and unboxing is there. And whatever collection classes we are providing inside the non-generic collection, right? All are going to be work on object data type. Second, that what we discussed is a hash table, right? And in this case, we discussed that it is going to store the data in the form of a key and a value pair, key value pair, right? That means you need to define the key, you need to define the value, right? And then you are going to store the data. But in this case, of whatever key you are providing, that can be of any data type. You can create the key as a string, as an integer, right? As a boolean, any kind of data type you can take as a key. But behind the scene, that key, right? Whatever you are providing, internally it will generate a hash code of integer type. That hash code value is going to be of int type, right? And based on that int type, the data is going to be sorted and stored in the collection, right? And we have already discussed. Today we are trying to complete the rest three non-generic classes like stack, queue, sorted list. And we have also discussed different operations on these classes like how to add element, how to insert element at a specified index position, how to retrieve the data, right? Then we have also discussed how to remove the element, how to clear all the element, to check whether an element is present in the collection or not, right? All these different operations we have also performed on the this array list collection and the hash table collection. Today we are going to keep the discussion, and we are trying to complete these three different non-generic classes today, like stack, queue, and the sorted list. Let's start the discussion from the stack only, right? So in your academics, you might be heard this word stack, right? Because for my experience in academic, you must have the concept called the data structure and algorithm, right? And in data structure and algorithms, we are keep focusing on stack, queue, linked list, array, all these things, right? And stack is one of the data structure, you can also say, and this data structure is going to work on the principle of LIFO, last in, first out, right? That means the element which is inserted into the collection as the last element, that element is going to the first element to be removed from the collection. And in data structure, you might be know how to create a stack, right? How to implement the different push operation, pop operation, pick operation, right? This thing you might be know from the data structure point of view. But in .NET framework, right, we do not need to create all those things, right? We do not need to create a stack, how to create we do not need to write the logic to create a stack. We do not need to write the logic to or from the different operation on the stack. Rather, all these things are already developed by the framework and they are provided one class to us. What we need to do, we just need to use the class and they perform the operations, right? So today we are going to discuss the stack collection, right? Stack data structure. But this stack, what we are going to discuss, it's a non-generic stack. And the same stack is also available in our generic collection. That is also we are going to discuss when we started discussing the generic collections, right? Let us discuss also what we are going to discuss. We are going to discuss what is exactly a stack and how does it exactly work. What are the different methods, properties, constructor provided in the stack class? How to create a stack? How to create a stack in C#, right? How to add elements into the stack? How to remove elements from the stack? How to get the topmost element of a stack, right? So if you are creating one stack, stack means what? You are putting the content one after the other, right? So if you want to paste the topmost element, then how you can paste? What are the different approach to paste the topmost element, right? That is what we are also going to discuss. We are also going to discuss how to check whether a element exists in the stack or not, right? Suppose you want to check whether this particular element is available inside the stack collection or not. How you can do this? And how to clone the non-generic stack, right? How to clone means already you have one stack and you just want to make a clone of that stack. I mean, with the same size, same element, everything is going to be same capacity, right? Everything is going to be same. And how you can clone it or how you can create a copy of that stack collection, right? All these things we are going to discuss today, right? So what is stack? So can anybody tell me before proceeding further? Anybody having any idea what is stack?
Yes.
Yeah, tell me.
Okay, the stack is a pile of things, one above the other. Two.
Okay,
So
can you
in order to be able to get one, you have to go all the way from the top to the bottom, right? Taking it back.
exactly?
Well, that's my idea of it.
Yeah, exactly. But in this case, you cannot get the item from the middle of the stack, right? It's not possible. So in this case, you have to follow the principle that is the LIFO. That means which element entered first, that element you have to paste first, then the other element like this. If you want that I am going directly and picking one element from the middle of the stack, then this is not possible. For that, you need to use other collections like ArrayList, right? Where you can access the element by using the index position. In this case, there is no such concept called indexing, right? In this case, see, every collection is created for a different purpose, right? Suppose you want to access the element by using the key, then you need to go for a hash table, what is we have discussed yesterday. If you want to fetch a particular element at any location, then you need to go with a array list, right? By using the index position, you can access the element. Or you can also use a hash table, right? Any element you can access by using the, by using the key. But in this case, you cannot access any particular element from middle of the stack. This is not possible. They are not provided any kind of mechanism, right? Where you can access any element from the middle of the stack. What they are provided? They are provided that last in first out access, right? One collection is there. If you want to access the element, you can only access the last element which is inserted. You cannot access the middle element of the collection, right? From the collection, right? If you want to access the middle element directly, right, then this is not last in first principle. Then why you should use stack? You do not need to use stack. You need to use either other collections like ArrayList and a hash table. Stack means here only you have to remember this access, last in first out, or LIFO principle that you need to follow. That means the element which is inserted last, you want to access that element. You cannot access other elements from the stack, right? Once you access that element and once you remove that element, then you can access the next element. Otherwise, you have to access the elements in a sequential manner, right? The last element, then the previous element, then the previous element up to the last element. But from the middle, you cannot access it. Understood? Guys?
Yes.
Okay. Right, because see, if you see, they are provided different collection classes. Why? Now, because each collection class having a different purpose, right? For different purpose means we have discussed array list, right? We have discussed array list. Array list means you can access by using the index position, right? They are provided something called a hash table. You can access by using the key. They are provided something called the stack. Here you need to access the element by using the LIFO principle, right? Good morning. See, so that means what? Now, each collection classes is specifically designed to work with a different. It's designed for a different purpose, right? Well, because if everything is possible in each collection, then why they are providing different type of collection? If whatever functionality you are achieving using hash table, if the same functionality is achieving using stack, then we do not require two collection, na? We are having two different collection. They are providing two different collection means the purpose is different, right? That is the point that you need to remember. Each collection class is having a different responsibility, right? Let us discuss what is exactly stack and how does it work in internal. The stack is a non-generic collection class that works in the LIFO principle. That works in the LIFO principle. LIFO principle means what? The last in, first out principle. What it means? It means we need to use stack collection when we want last in, first out access to the items of a collection. So when we want last in, first out access to the item of a collection,
I totally forgot about Edge. Piss me off, man.
Right? So when we need last in, first out access to the items of a collection, then we need to go with the stack collection, right? What it means? What do you mean by last in, first out access? It means the item which is added last to the collection will be the first item to be removed from the collection. That means the item which you added last, and if you want that item to be removed first, then in that case, you need to use stack collection. Clear?
Yes.
Right? Clear or any question?
No, it's clear.
Okay. That means, and guys, remember, when we add an item into the stack collection, then it is called pushing an item or push operation, you can say. Similarly, when you remove an item from the stack, then it is called popping an item, or you can say pop operation. That means on the stack, you can perform push operation as well as you can perform pop operation. So simply remember, stack works on the principle of LIFO, last in, first out. And if you want last in, first out access to the elements of a collection, right, then you need to use stack data structure. And that means what? Now it means the item which is added last in the collection will be the first item to be removed from the collection. In this case, you can see this is a collection of books, right? So this is the first, second, third, fourth, fifth, sixth, seventh, eighth, 9. So this, the topmost book is the last item which is inserted into the stack, right? And if you want to remove, then this is the first item is going to be removed from the stack. You cannot remove this one or this one from the middle of the stack. You have to remove this one as the first item, right? This is the principle of stack. And if you want some kind of accessibility or some kind of functionality like this, then you need to go with the stack principle, right? So see, you can, the last book which is added to the stack will be the first one to be removed from the stack. It is not possible to remove a book from the middle of the stack, right? From the middle of the stack, it is not possible. Only possible from top of the stack. Whatever you insert, that will be inserted on top of the last item, right, which you inserted. And if you want to remove the last item which was inserted into the stack, will be the first item to be removed from the stack. Clear or any question from anyone how this stack is worked? Guys?
It's clear.
Okay. Okay, in non-generic stack collection, the non-generic stack collection works in the same principle, element are added to the stack on top of each other. When we add item into the stack, it is called pushing an item. The process of adding an item to the stack is called a push operation, and the process of removing an item from the stack is called pop operation, right? For better understanding, you can look at this image. This is a stack. This is the first item. This is second item. This is third item. The push operation is going to perform on the same end, as well as the pop operation is also going to perform on the same end. So here you can see push operation pushing an item. And here, if you want to remove the item, then again on the same end, you are going to remove the item. So this is nothing but how the stack is work. And this example is exactly same as this books example. Whatever books you want to insert, that you want to insert in this end only. And if you want to remove, then also you are going to remove from this end, right? So this is the same example, right? And guys, this stack collection, what we are going to discuss, this stack is available as generic stack as well as non-generic stack. So today we are going to discuss the non-generic class, right? Non-generic stack class. And in once you start discussing the generic collection, then we will discuss the generic stack, right? And this non-generic stack, right, it belongs to the system.collection namespace. And if you are working with the generic stack, that is stack of T, then that class belongs to your system.collections generic namespace, right? So here in this session, right, we are going to discuss non-generic stack collection, right? If you go to the definition of stacks, then you will find this. What is there? I collection, I enumerable, and I clonable, right? I collection means it's a collection. I enumerable means you can look through this collection. I clonable means you can create a clone of this collection class, right? And you can see there are different constructors, right? One is not taking any parameter. Another constructor
We're not
is
able to hear your voice.
Sorry, anyone saying anything? Guys? Okay. So there are three different overloaded versions of this stack constructor.
No, you're good.
So three different constructors. One is doesn't take any parameter. Another one is taking a collection, and another one.
Explain what.
Who is saying anything? Who is?
You never explained the iconable thing. You got cut off. You never explained what iconable means.
What is this? Okay. So these are the three different constructors which you can use to create an instance of the stack, right? We have already discussed what is this I collection, what is this initial capacity, and what is this default constructor, right? If you want to create a stack by taking a collection, right, then you need to use this one. And here you can provide the initial default capacity. What is I clonable? See, what is I clonable means it's a it's actually a interface, right? And you if you and see what is I collection, what is I enumerable, what is I clonable, all these interfaces we are going to discuss later, right? But for now, what you need to remember is, right? Okay. Right click on the stack, go to definition, right click on this iClonable, go to definition, and see supports cloning, right? Supports cloning, which creates a new instance of class with the same value as an existing instance. Did you attend yesterday's session?
No, that's when I was waiting in the lobby and you changed the time. I missed it.
Okay. So see basically what I want to make you sure that suppose you create one collection and you want to clone that collection. Clone in the sense you want to create a copy of that same collection by taking the same data elements, taking the same default initial capacity, or taking the same initial capacity what you have provided, right? If you want to make a clone of that collection, then you can only do if your collection implement the iClonable interface, right? So that is what we are also going to cover. See, in this case, this is iClonable means you can see there is a clone method available inside this class, right? And once you call this clone method on the stack instance, then it will make or it will create a clone of that object, right? and that cloned object is going to be have the same default initial capacity, right? The same number of elements. That is what is meaning for iClonable. If iClonable is not implemented, then you cannot make a clone of that object, right? We are going to discuss this thing practically, but this thing we have already discussed yesterday with all the with array list we have discussed how to create a clone. With the hash table we have already discussed how to make a clone, right? Again, we are also going to discuss the same thing using this stack. Clear? What is clone? How to make a clone? We'll see practically. Clone means just create a copy of the object, right? If you are creating one stack with 10 elements, then you want to make a copy. That copy version of the actual object is going to contain also the same 10 object, right? If clone is not there, then what you need to do? You need to create an instance. You need to look through all the original elements, and then you need to create different elements and store the elements, right? This is not for this is not what we are going to do. We are just going to make this clone method use, and that clone method is going to create a clone object of our actual data, right? So whatever data or whatever collection we have, that we will create a clone by using the clone method. And this clone method we can only call, and this is going to work because of this iClonable interface. This iClonable interface provides this method, and by using this method we can do this. And we will see this practically, right? And we have discussed these three different overloaded version of the constructor. No need to explain this thing again. It is basically used to create a new instance, right? With the default initial capacity. Here it is going to create a new instance of a non-generic stack class that contains elements copied from this collection. Suppose you create one collection and you want to create a new collection by copying the element of the older collection. Then in that case, what you need to do? To the constructor of this stack collection class, you need to pass the older or already created collection instance, right? That will be created by using this new constructor, right? Then this is the initial capacity. We have already discussed what is this capacity, right? How the capacity is increased in .NET framework, right? And every time it is going to be doubled. Suppose you created one constructor by providing the initial capacity 2, then first it will allocate the memory for 2 elements, right? Once you are the third element, then the capacity is going to be doubled. 2 becomes 4. And once you add 4 element, and when you add the 5th element, then the capacity is going to be doubled. That will become 8. And when you try to add the 9th element, the capacity is going to become 16. And when you are the 17th element, the capacity is going to become 32, right? In that way, it is going to be war. And in this case, the default capacity is going to be 4. That means once you are the 4th element, that is fine. When you are the 5th element, the capacity becomes a double, right? That will become 8. That is what we have already seen in our last session, right? So now we are going to discuss how to create an instance and how to add elements to a stack collection. What are the different options to add elements to a collection, and how we are going to access the elements of a collection step by step. So first of all, this collection stack non-generic collection belongs to System.Collection namespace. So first you need to include this namespace. I'm going to use this default constructor. So I'm going to use that default constructor, and I'm creating an instance of the stack by using this syntax. Stack equals to new stack. This is my object creation statement, and that reference is stored inside this video. So once you create an instance, right, then how you can add elements to the stack, right? Previously we have discussed add method, right? So if you remember array list and if you remember hash table, we are having the add method. By using that add method, we can add element to the array list, and by using that add method, we can insert elements to the hash table. But here, from the beginning, I have told you we are having 2 kind of operations. One is push operation and another is pop operation. So push operation basically to add element on top of the stack. And the pop operation is basically means to remove the element from top of the stack. So if you want to add element, then you need to use this push method. And if you want to remove element, then you need to use the pop method, right? So if you go to the stack class, then you will see there is something called the push method. Yes, push method is there. This push method basically used to insert an element at the top of the stack, right? And the pop method, you can say, removes and returns the element at the top of the stack. And this basically pick method is there. This is going to return the element from the top of the stack. We are going to discuss these three methods in detail, right? So, so basically, give me 1 minute, guys. So basically, what you can see, we are using this push method to add elements to the top of the stack. So now let us try to understand these things. Then we will understand all these things one by one, right? All these methods, clone method, pop method, pick method, right? Or everything we are going to discuss. See, because we need to discuss step by step so that you can easily understand. This is the creation. So here we are creating an instance of the stack class. That means one stack collection is created, and if you want to check the default initial capacity, right, what you need to do, you just need to call the capacity method, right? So here, what I'm trying to show you, capacity. So capacity means there is a property called capacity, that is stack dot not capacity. Here you can see count, right? So count means it will show you the number of elements, right? So in this case 0, and here you can see, right, here you can see the capacity. It means the number of elements that you have. And you can see as it is a stack, and as this stack belongs to non-generic, it's a non-generic class, means it belongs to System.Collection namespace. So this stack is going to work on object data type, and hence you can see here I'm adding integer value, here I'm adding string value, here I'm adding floating point value, here I'm adding boolean value, here we are adding long double value, here we are adding character value. So any type of data you can add. And as this stack collection, right, as this stack collection implements the enumerable interface, so you can simply use a for each loop to iterate through all the items from the stack collection, right? That is what I'm using for each loop, and I'm providing this stack collection to the for each loop. And by using this object item, each item will be looping through this for loop will loop all the item, and the item is going to print it on the console. Which unmute? Guys, while I'm explaining, please try to mute yourself. I will give you enough time to ask your question, right? So in this case, once I run the application, right, then you will see that initially the count is going to be 0, and here the count is going to be 6. See, capacity 0, capacity 6. As soon as you added element, the capacity is going to be increased. There is no need to mention the size, right? Even though if you mention the size, this is also going to work, right? Suppose what I'm trying to do, initial capacity, right? So here you can also set the initial capacity to, right? So you can initial capacity 2, but even though you set the initial capacity 2, you can still store 6 element, and that is fine, because as you added element, right? As you added element, the size is automatically grows. This is the advantages of using this collection class, right? But this is not possible in array list, right? You can see all the elements. So whatever elements you have added, right? So this element is first, then this, then this, then this, then this, then this. So this is the last element, right? Then you can see while I'm retrieving the element, which element is come first? The last added element or not?
Yes, last one.
Yes,
Yeah,
sir.
right.
This is the last, then this, then this, then this, then this, then this. So the point that you need to remember, so the both the operation is going to be performed at one end, right? And when you are inserting the element, this is push, and when you are retrieving or removing, then that is going to be called pop. So in this case, we are not removing, we are just traversing all the element. But as it is a stack, you can see the element which is added last will be the first item to be accessed, right? So this is how you can add, this is how you can create an instance of stack collection, right? This is the syntax. This is how you need to add the element, and this is how, right, you can access the element, right? But apart from this, many things are there, right? Now you understand this push operation, right? Now the next thing that what we are going to discuss is how to remove elements. So in this case, we have understand what we understand. We understand how to create the stack, how to insert the element, and how to access the element. But in this case, it is not possible to access any direct. If you want to access this element directly, this is not possible, because from the middle of the stack you cannot access any element. You have to access element in a sequential order. That is, the element which is added last will be the first one that you can access. Right now we are going to discuss how to remove element from a stack, right? So there are two methods provided by the stack collection class to remove the element. One is pop method and another is clear method. So what this pop method is going to do, it is going to remove and return the element from top of the stack, right? So in this case, you are adding the element like this, but in this case, this is the topmost element or not? Yes or no? This element is there in the top position or not?
Yes.
Right? Suppose you use this pop method, then what this pop method is going to do, it is going to remove the element, right, from the stack, as well as it is going to return this element. It will remove the element, it will return the element. Understand? Right? We will see practically. And what is this clear method means? It is going to clear all the elements. It is going to clear all the elements from the stack. Okay, let's see this thing practically so that you will understand. Right? So this is my stack. These are the elements which have all added into the stack, right? And this is the count which is showing the number of elements that are available in stack. And I'm just printing the elements by using a for each loop. And then I'm using the stack.pop method. See, in this case, this stack.pop method not only remove this element, but also return the element after removing it. So here you can see deleted element. This element is going to be deleted from this collection, as well as this method is going to return that element, right? If you go to the pop method definition, then you will see the return type is going to be object. It is not a void, right? If you void, then it is not returning anything. But in this case, the return type is going to be object, means it is going to return some data. And what data this method is going to return, it's nothing but the element that it removed, that element it is going to return. And the return type, you can say the return type is going to be object. So what it means it can return any value. It can return character, it can return integer, it can return string, it can return employee, student, everything it is going to return, right? Then what I'm trying to do, after removing the item, I'm just checking, right? What is the stack count. And in this case, you can see I'm just checking the stack count, and see initially the number of elements is 6. So this stack count is going to show me 6. After removing this element, the count should be 5. And here the second time when I'm using the for each loop, it should print the element except the last element which we have removed. Okay, let's see this practically, run the application. See, please observe the output. Initially, all stack elements count is 6. 1, 2, 3, 4, 5, 6 elements are there. Deleted element, it is showing A. Why it is showing there? Because the stack count not only delete A from the list, right? But also it will return that element. So it can say return element. After returning the element, right? After the delete operation, or you can say after the pop operation, again we are printing the count. Now the count is showing me 5, means what? Now one element is deleted from the stack, and then when I'm using a for each loop to traverse all the element or iterate all the element, right? Then you can see A is not there in the list. And now which one is the latest element or top element? After removing A, 67.8 becomes the top element. And if you remember, this is the top element, and once you remove this element will become the top element or not?
Yes,
Yeah.
obviously.
right?
Yeah.
So any question from anyone how this pop method is working?
No.
Okay. Right. And one more thing I forgot to include here, right? Let me also add that, right? So there is a method called clear method, right? If you want to remove all elements from the stack, right? Remove all elements from the stack, then you need to use the clear method. So what is my stack? Stack dot clear method, right? Once you call the clear method, right? Then you will say, okay, I'm again doing the same thing, right? All stack elements after clear operation, after clear method, right? So in this case, you should see the count is going to be 0 and this for loop will not work because there is no element, so this loop is not going to be work. So let me run the application. See, all stack elements after clear method 0, and here you can see there is nothing to print, right? So let me copy this example to yeah. Right, and let me take the screenshot from here only. Right, so let me format this also so that it will look better. Right, so this is the process of how you can remove elements from the collection. Right now, if someone asks you how I can fetch the topmost element from the stack, so what is the process to fetch the topmost element from the stack? Right, you have seen one option, that is pop. So, but if you are going to use this pop method, it will not only not only return the topmost element, but it will also remove that element or not. So if you are using
Yes.
pop method, it is going to return the topmost element, but it will also remove that element from the collection. Then what is the other option is? Other option is a pick method. So if you are using the pick method, then it is going to return the topmost element, but without removing it, right? Then what is, if someone asks you what is the difference between pop and pick method, then what you need to do, there is only one difference. The difference is that pop method is going to return the topmost element, but after returning, it will remove the element from the collection, where on the other hand, pick method is going to return the topmost element without removing it. And this is the only difference between your pop and pick method. Is that clear? Yes.
Yeah. Yes.
Yes, sir.
Okay. So now you can see this is my same stack. I'm adding few elements to the collection. Initially, the number of count I'm showing here total elements present in the stack, right? And here fetching the topmost element using the pop method. But in this case, it will return A. But after returning A, it will remove the element, right? And after that operation, then I'm showing the count method so that the second time here the count is going to be, what will be the count value in this case? 6. Yes or no? Because total 6 elements are there. In this case, once you perform the pop operation, the count will become
Five.
5. Yes, 5. So in this case, I'm using the pick method, right? And in this case, I'm using the pick method. So for this pick method, what it will return, can anybody tell me?
Yes.
A is removed already now from this statement.
67.8.
Yes, when
67.8.
when you use this pop method, means it is not only return M, but it will remove that element from the collection. So if this element is removed, then this will become the next topmost element now. So in this case, when you return, right, in this case, it is going to print A. But in this case, it is going to print 67.8 if our understanding is correct. And in this case, it will only return the element. Does this method remove this element from the collection?
No,
No. That means again the count is going to be here 5,
5.
right?
Correct.
So let me, so in this case, it should be the output 6A56785. If this output if we got, then our understanding is correct, right? Okay. So first it is printing the value 6, right? The 6 here we are getting 6. Next is A, we are getting A. Next is count 5, we are getting 5. Next the output is 67.8, yes. And next we are getting the count as 5, and here we are getting the count as 5. Clear? Or any question from anyone related to this push and a pick, push, pop, and pick method?
No, it is clear.
Right now the next thing, and here I have also mentioned the difference. If you want to remove and return the top element from the stack, then you need to use the pop method, right? And if you only want to return the element from the stack without removing it, then you need to use the pick method. And this is the only difference between these two methods. Clear? Now now next, what we are going to discuss, we are going to discuss how we can check whether an element exists in the stack or not, right? See, already we have discussed many things, right? In the dictionary, we have a 3 options: contents, contents key, contents value. Why? Because in dictionary, we are having the option key value pair. So that's why they are providing the options to access, to check one value by using the contents key method or contents value method. But in this case, there is no key concept, right? We are not adding the element by using the key, right? Here we are directly adding the value. So there is no contents key, contents value method. So in this case, what method they are provided us is a contents method. So to this contents method, we need to specify the object that we want to search. And if that object is available inside the stack, right, then it is going to return me true. If the object is not available, right, object in the sense the element. If the element is available, it will going to return me true. If not available, it is going to return me false. But in this case, again, it is going to do a traversing. That means what? It is going to check the element one by one, right? Once it found one element, if a match is found, then it is going to return me true, else it is going to return me false, right? See, in this case, also I'm having the stack, I'm adding few elements, but in this case, you have to use the push operation to add the element. So as I already always mentioned, if you are using contents, always use inside this try block, inside this if condition. So if stack.contents hello, if this value hello available inside this stack collection, then this method is going to return me true. And in that case, I'm just writing this statement, element hello is found, right? If this hello is not available inside this tag, then the else block is going to be executed, and in that scenario, it is going to print element hello is not found. Then I'm checking world, right? Again, the same thing is going to happen. If the element is available or element is found inside this tag collection, then this statement is going to be printed, and if not available, then this statement is going to be printed. Clear? Or any question? Right? So
Clear.
in this case, let me run the application. The hello is available in our collection. For hello, so it is going to say element hello is found, but the element world is not available in our collection. See, here world is not available, so it is showing element world is not found, right? So this is how you need to check whether an element is available or not in our collection. Clear? Guys?
Yes.
Yes.
Right. Now coming to the last piece of our stack collection, and Ty was asking me that question, sir, what is the use of iClonable interface? Now coming to that point, right? If you want to clone the non-generic stack collection, then you need to use the clone method, right? Provided by the stack collection class. But this clone method is only going to work, right? If your collection implement the iClonable interface, right? There is an interface called iClonable. If this iClonable is implemented by this interface, then only this clone method is going to work, right? And if you go to the iClonable interface, then you can see supports cloning. Cloning means you just need to create a copy, right? And that is what it is also telling here, right? You just need to create a copy. So here you can see this is also create a shallow copy of the collection stack, right? It's going to be create a copy of your collection object, right? For that purpose, we are going to use the clone method, and the clone method only going to be work when your class implement the iClonable interface, right? In this case, I'm creating my stack. This is my original stack. And in this stack, I'm having 4 elements, right? And I'm just printing the elements of the 4. I'm just printing the elements of my original stack, right? Then what I'm trying to do, I'm creating a clone of this stack. So this is my original stack. Of this original stack, I'm calling the clone method, right? And this clone method is going to return me a stack. So that's why I'm typecasting this to stack, and I'm storing that inside this variable. So now this clone stack and this stack is going to be same. In the sense, they are pointing to a different memory location, but in this case, the element, right? The element of this stack and the element, okay, so let me do one thing. Right, and this is my cloned stack, right? Cloned stack, again I'm using a for each loop to print the element of the stack, right? So let me run the application. See, in this case, this is my stack elements 67314 hello, and clone stack elements 67.8 3.14 hello and 10. If you remember, right, after cloning, right, after making a clone, I'm adding 2 new more element to my original stack. But is those elements are showing in the clone stack?
No, not showing.
Not showing. That means what? Now this memory location, right? It is not pointing to the same memory location as the stack. It's completely a new memory location, right? It's completely a brand new copy of the stack, right? That means both are pointing to different memory location. Don't think that if I'm creating a clone like this, if I'm adding some element to my existing my original collection, after making the clone operation, those elements are available to my clone stack. Don't think that. Why? Because in this case, it's a shallow copy. Shallow copy means both are having different memory location, right? This is pointing to some other memory location, and this is having the my original memory location. So in this case, this element you will not find inside this clone stack, but these are only available to my original stack. So if you want to make sure this clone method is going to work, first of all, your class should implement this iClonable interface. This iClonable interface provides the cloning functionality, right? So how? See, if this clone method is not available, right? If this clone method is not available, then how I can implement this functionality? Can anybody tell me? I want to create a new collection, right? With the name, this one only, right? I want to create a new collection with the name, this one, stack, right? I want to create a new collection with the name clone stack, but this collection should contain all the elements that are available inside this stack. Any idea from anyone how we can implement this without using this clone method?
Or you want them to be in the same order? You want them to be in the same order, or it could be in any order?
It's going to be in the not in the same order, in other order, right? I just want the elements, right? Or in this case, order does not matter.
Okay.
I think using the for loop, we can fetch the elements from the previous one and we can assign it to the new stack.
How you can use for loop here? Because the indexing is not available here. For loop is you can use when you want to access the element by using the index. But indexing concept is not applicable to this collection. You understand?
You use the for each. Use the for each loop and read the first one and push it in the second one.
Exactly. So what you need to remember, you need to use a for each loop, give that stack like this, and then just use the stack method. So here instead of for 10, you just need to use this item. Clear? Clear? So these things you need to write manually, but if you are using a clone method, then in this case, the order is also going to be same, right? The order in which you are adding the element, in the same order, it is going to add the element inside the stack. Understood? But in this case, you will get the output in a different order, right? Let me run the application.
Sorry, is that a clone stack dot push of item?
Oh, sorry. That's why it is showing me error. It should be clone stack, not stack. See, in this case, you are getting the output in a different order because in this way, it is accessing the last element, right? But if you use, right? But if you use the clone method, right? So it is going to be a clone of your original stack, right? Whatever element, whatever the order of the element, everything is going to be same. Yes or no? So this is the use of a cloning, cloning interface. Clear, guys?
Yes, sir, clear. Yes.
Okay. So this is all about your stack collection, or you can say stack data structure. And if I'm not wrong, in your academics, you might need to create the stack manually. You need to write the logic to implement the push operation, write the logic to implement the pop operation, pick operation, right? Everything you need to write manually. But in this case, no need to do anything manually. This class is already provided by the framework. You just need to create an instance and use the method and perform the operations, right? This is all about your stack. And coming to the summary, stack are used to store a collection object in LIFO style. That is the element which added last will come out first. Pop operation, you can add element. Push using push method, you can add element. Using pop method, you can remove and return the topmost element from the stack. And using pick method, you can return the topmost element right from the stack without removing the element. This is the three methods that you need to remember, right? And this stack is going to work in the LIFO principle. Clear?
So in the previous example, two more elements are added to the clone stack, right? That
yes. No, I'm not adding the clone stack. It is adding to the original stack. This is the example. So in this case, if you are looping through this stack, then you will find these two elements. But I'm here looping the clone stack. You added the element to the original stack. So after cloning the element, right? Once you perform the clone operation, this stack is different and this stack is different, right? There is no link between them. And once you add the element to the original stack, this element will not available to your clone stack because both are having different memory structure.
Okay.
Right. So in this case, if you use the original stack, right, then you will see the elements, right? So you will added elements, right? 67.8 and a half. You can see those elements. See, 67.8 and a half. You can see those two elements here, right?
Okay.
Any question from anyone related to stack?
One question, like this for loop can be used only for the collections which are index based, is it?
Exactly. If index is not there, then how you can use the for loop to access the element? Right? This thing you need to remember. Index means without indexing, if index position is not there, for loop means you are using one loop variable which is going to start from 0, 1 or anything else. And by using that loop variable, you can access the element. But if there is no index, then how you can access the element by using for loop? And this is the reason why, right, the framework specifically designed this for each loop, right? You can use this for each loop with all type of collections, but you cannot use for loop for all type of collection. The collections which are having indexed based, for those collections you can use for loop, but for each loop you can use with any kind of collections, right? Clear?
So
Yes, clear?
to implement the for each loop, it should implement the I enumeration interface,
Exactly.
okay?
I enumeration class is already implemented now. I enumerable. Right? So any kind of a collection you take. Suppose we are working so far with array list, right? If you go to the array list, then you will definitely see that it is implementing I enumerable, right? And this I list is implemented means you can access the element by using the index position, right? And if you go to hash table, right? Hash table, if you go to the definition of a hash table, then you will see that it is implementing I enumerable, right? So this is the point that you need to remember. Now we are going to discuss one more collection class, right? Queue. And if you go to the definition of queue, then you will see that this is implementing I enumerable, right? That means you can use only for each loop to access the element. Clear?
And this stack, like what is the where do we use this kind of collections in
I'm saying
application?
now, I'm saying now, whenever you want to implement that LIFO kind of a principle, right? You want to implement the LIFO kind of principle, right? The item which is added last will be the one to be removed first, right? Then in that scenario, you need to use stack. But for me, in my real-time application, right, I never use the stack concept, right? Because I never got any kind of scenario, right, where I can use the stack operations. But yes, this data structure is there, right? If you need some kind of functionality, right? If there is some requirement, right, where you need to remove the element which is added last, then you need to go for stack operation. But for me and for anyone who is working professional, and I might be not sure whether they are using the stack queue or not, because we never got such requirement where we need to remove the last added item. Anyone which working professional, anybody here who use this stack and queue in their project?
Oh, sir.
No. But yes, this functionality is there. When you are working, right, you will got the requirement, right? In that requirement, if you find this type, this kind of functionality, then definitely you need to go with stack collections, right? But generally, I never found any real-time scenario, right? I never used any kind of application in any of my application. I never used this tag and okay. The next concept what we are going to discuss is queue, right? So again, the same thing. So it is a collection, it is a non-generic collection class, but this collection class works on the principle of FIFO, first in, first out, right? So if you want to provide access to the element by using the FIFO principle, then you need to use this queue collection, right? Queue collection again belongs to the System.Collections namespace, right? And what we are going to discuss the same concept. What is queue? What are the method and properties of queue collection class, how to create a queue, how to add elements into a queue, how to remove elements from the queue, how to get the first element of the queue, right? How to check whether an element exists or not in the queue, and how to clone the non-generic queue collection class. All these things, what we discussed with stack collection, again, we are going to discuss with queue collection class. Give me 1 minute. Right? So what is queue? Right? Queue means it work on the principle of first in, first out, right? So we need to use queue collection, right? When we need first in, first out access to the items of a collection. That means the item which is added first will be the item to be removed first from the collection, right? And when we add item into the queue, then it is called enqueuing an item, right? Or you can say enqueue operation. Similarly, when we remove an item from the queue, it is called a dequeuing an item, or you can say dequeue, right? So we need to understand this queue collection. For this, look at this image, right? So imagine a queue of people waiting for a ticket, in the cinema counter, right? In the cinema hall. Normally, the first person who is there in the queue will get the chance to get the ticket first or not, right? If this is the first person who is there in the waiting queue, right? This person will get the ticket first, right? Then this person, then this person. That means what? The first person who is there or who is entering into the queue will be the first person to be served by the queue, right? So this person will be entered first, and this person is going to remove first from this queue. And this is nothing but your FIFO principle, right? First person in the queue will serve first, right? And this implementation, if you want to implement in your application, right, then you need to use this queue or data structure, right? This is the example, right? So this is first in, first out. I have insert this element first, right? So when I'm inserting any element, right, then I'm going to tell this as enqueue item. So enqueue means this is the method, right? This method, the process of inserting the element into the queue is nothing but your enqueue, and the process of removing the element from the queue, it is nothing but your dequeue. The insertion is done at one end, and the deletion or removing the item is done on another end. The item which is inserted first, in this case 1, will be the first item to be removed from the queue. And this type of functionality we can implement by using a collection class provided by the .NET framework is nothing but your queue. Again, this queue collection is implemented as both a generic and a non-generic, right? The generic queue collection class belongs to the System.Collections.generic namespace, and the non-generic collection class belongs to System.Collections namespace. And now we are going to keep focus on discussing this in non-generic queue collection class. And once we start discussing the generic collection, then at that time again we will be discussing this queue collection class, right? The characteristics. Enqueue means it will add an item to the end of the queue. So this is the queue, this is the first, second, third, fourth, 5. This is the starting, this is the ending. So if you want to add an item, it will be added at the end of the queue, right? Dequeue removes the oldest element from the start of the queue. This is the first element. So dequeue will be going to remove. This is the oldest element, right? Oldest element in this case 1. So the first element is nothing but your oldest element is going to be removed by the dequeue method. But in this case, dequeue is going to remove and return the element, right? We're going to remove and return the oldest element from the queue, whereas the pick method going to return the oldest element from the queue without removing it. The same thing. In our stack, in the stack case, this enqueue method is nothing but a push method, right? This dequeue is nothing but your pop method, and the pick method is going to be same. So this push method is renamed as enqueue in this case. The pop method is renamed as a dequeue in this case, and the pick method is going to be same in both stack and queue. But the difference is that in this case, the deletion is going to be performed from this end, and the insertion is going to be performed from this end. But in the case of stack, both insertion and deletion is going to be performed from the top of the stack, right? So in this case, when you add a new item, that will be added at the end of the queue. And when you want to remove an item, then that will be performed from the start of the queue. And pick means it is going to return the oldest element without removing the element, right? The capacity of a queue is the number of elements the queue can hold, right? The number of elements the queue store is nothing but the capacity of the queue. The non-generic queue collection allows both null and duplicate value. You can store null value and you can also store a duplicate value, no issue, right? And this is the constructor. You can see queue class taking some constructor, and they are having some properties, right? So again, we are going to use the we are going to perform everything from the scratch. So we are going to use the constructor which does not take any parameters. So similar to the stack collection, again, there are a different overloaded constructor, right? No need to discuss this again and again, right? The concept is going to be same. Constructor means they are going to create an instance of the class, right? In this case, queue class constructor means they are going to create an instance of the queue class. Let us see how to create a queue collection in .NET Framework, right? First of all, yeah, you can run this chapter phase. Yeah, I'm doing the same, right? So in this case, you can see this is the first of all, you need to import the using namespace. I mean, from which color namespace this class belongs to. In this case, it belongs to queue collection class. Then I'm creating an instance of the queue collection class, right, by using the constructor which doesn't take any parameter. And I already told you how to add element means you need to use the enqueue method. The enqueue method is going to add the element at the end of the queue. Let me show you these things practically. So in this case, this is my queue collection. I'm creating an instance of a queue collection, and here I'm using the enqueue method to add the element into the collection, and then I'm using a for each loop to loop through all the elements of the collection. See, I'm using for each loop because this collection class implements IEnumerable interface, right? So you can see in this case, it is not going to print the order, right? Right, the last element which is added is not going to be printed first. In this case, the element which is entered into the queue first is the first element to be printed here, right? The reverse order of your stack collection, right? So this enqueue method you can use to insert element into the stack collection. Is there any question related to this enqueue method?
No.
Right, fine. This is, if you understand the stack, then queue is not that difficult to understand, right? Again, now we are going to see how to remove the element, right? To remove the element in stack, we have pop method, but in queue, we have a dequeue method. So dequeue method is going to return and remove the oldest element from the queue, right? That means it will not only going to return the oldest element, but it will remove that element from the queue. And clear method means if you want to remove all the elements from the queue, then you need to use the clear method. Let me show you this thing practically. See, this is my queue. I'm adding few elements, right, to the queue. I'm printing all the elements here. I'm using the count method so that you can see the number of elements are going to be the number of elements available in the queue is going to be represented by this count variable. I'm using queue.dequeue method. This method, if you go to the definition, right, the return type of this method is going to be object. That means if you see the definition, remove and returns the object at the beginning of the queue, right? The element means the first element which entered into the queue is going to be returned and removed by this dequeue method, right? Once you remove, then I am again printing the elements and again I'm printing the count here, right? And then I'm using the clear method. This clear method is going to remove all the elements, and after clear method, I'm again doing the same thing, right? I'm again printing the count, and in this case, the count is going to be 0, and in this case, this for loop will not work because the queue is having 0 elements, right? Let me run the application. Right. So initially there are 6 elements. The count is showing 6. 1, 2, 3, 4, 5, 6. Right. Once we deleted some of the element, right? Once we deleted, the first element is going to be deleted. So in this case, 101. After you delete the first element, this is the collection, right? Having 5 elements, count is 5. And once you call the clear operation, then the count is going to be 0. Any question from anyone, or what is this enqueue method, what is this dequeue method, and what is this clear method? This is same as push method, this is same as your pop method, and this is the clear method. So in this case, it is not going to delete the last inserted item, but instead it is going to delete the first inserted item. This is the difference between the pop and a dequeue method. Any question from anyone?
No.
No questions.
Okay. Then the next operation is that how you will get the first element. See, if you want to get the first element, then we have 2 options. What are the options? You can use a dequeue method or you can use a pick method. If you use dequeue method, then it is not only going to return the first element, right, but also it is going to remove that element from the collection. But if you are using pick method, then it is going to return the first element from the collection or oldest element from the collection without removing that element, right? Let me show you this thing practically. So this collection having 6 elements, you can see the count. I'm using the dequeue method, means this collection is going to return 101, but after returning 101, it will remove that element. Once this element is removed, then this will become the oldest element. So in this case, when you call the pick method, right? In this case, when you call the dequeue method, it will return 101 and then remove 101, right? Initially, the count is going to be 5. After removing 6, initially the count is going to be 6 because we are having 6 elements. After removing this element, the count is going to be 5. And in this case, this peak method is going to return this element because 101 is the oldest element initially. Once you remove that element, once this person who is there in the queue first, once that person get the ticket, he will remove from the queue. The next person who is behind the first person will get the ticket. So in this case, this LO will become the oldest element, right? And in this case, this method is only going to return the element, but it will not remove the element. So the count is going to be 5 in this case, right? Now let us run the application and see the output. See, we are getting 6, right? We are getting first 6, then 101, then we are getting 5. Hello, 5. Any question from anyone?
No.
Right, this is the same operations what we have done with the stack. This is the same, right? Now what is the difference between if someone asks you what is the difference between this dequeue method and this pick method, then you have to tell this dequeue method is going to return the oldest element, but after returning it will remove that element from the collection, and this pick method is going to return the element, the oldest element, without removing that element from the collection. This is the only difference between dequeue and a pick method, right? Now, if you want to check whether an element exists in the collection or not, then you need to use the same contents method. To the contents method, you need to pass the object or element that you want to check whether that element exists or not. If you want to check, then you need to use that contents method. In this case, you can see this is my collection having few elements, right? Then I'm looping through the elements, right? Then I'm checking this element hello is available inside this queue collection or not. If available, this method is going to return me true. If not available, this method is going to return me false. If it returns true, the if block is going to execute. If it returns false, the else block is going to execute. And again, I'm doing the same thing with this world element. And in our collection, you can see the element hello is there. So in this case, this statement is going to be print because this contents method is going to return true, and the world is not available in our collection. So in this case, the contents method is going to return me false, and in that case, the else part is going to be executed. Let me run the application and show you the output. See, element hello is found, element world is not found. Clear? What is this contents method, guys?
Yes.
Okay.
Yes.
And the last one, what we are going to discuss is the clone, right? How to clone an object, right? Clone means how to create a copy of the object. The same thing, right? Same thing in the sense, if you go to the queue collection class, it is also implementing the iClonable interface. As it implements the iClonable interface, I can make a clone of my queue collection. So in this case, this is my queue object, my original collection. I'm making the clone method and I'm converting this to a queue, right? I'm storing that inside a queue variable, and then I'm looping through this clone queue method. So in this clone queue, right, it is exactly same as your queue. Whatever number of elements, whatever the order of the element, everything is going to be same, right? Now in this case, if you run the application, then you will see both are having the same data. Clear, guys?
Yes.
Yes, sir.
Okay, so this is all about your stack and a queue, right? And if you go to the definition, right, summary point, then you can see this is work on the FIFO principle. That means if you want first in first out access to the element of a collection, then you need to use queue collection. NQ method is basically used to add element at the end of the queue. DQ method is basically remove and return the first element or oldest element from the queue, and pick method is going to return the element or oldest or first element from the queue without removing the element, right? This is the three method that you need to remember, and this is the principle that it is followed, right? So any question from anyone related to this queue collection? Again, I do not find any kind of real-time scenarios, right, where this principle is implemented. Right? Even if you want to implement some kind of a ticket booking functionality, right? Ticket booking functionality means you have a collection, any number of people can enter. When they entered, you need to add them into the queue, and when they serve, then you need to remove the person from the queue. If that kind of functionality you want, then you can use this queue collection class, right? But in generally, I never used this stack and queue in any of my applications. Right?
So actually, yeah. So I have come across this queue collection scenario. Like, actually, it is mainly used where the system requests are being generated and they are queued up in a queue where they are going to process. Normally, asynchronous processes.
Okay, so once it processed, then you need to remove that from the queue, right?
Yes. Like there will be a service bus queue where all the message requests from particular system will be generated. Suppose if you are sending mail asynchronously,
So basically,
and
yeah. So basically, you are talking about messaging pattern, right?
yes, yeah, messaging and request also, like to execute. Suppose if you want to execute any CRUD operations, and those are being a huge number, and those things will be queued up in a queue, and those will be processed on their priority, like first in first out, whichever is being triggered first, and they'll be served first, like that.
All right, that is fine. So that is one scenario, right? You are having a queue where you can store multiple records, and you need to process the records one by one. But the record which first inserted, that will serve first. In that case, you can use this queue collection class, right? Once you process that record, you just need to call the dequeue method, which will remove that record, right?
Yes. I mean, again, that is the like system generated functionality. We are not going to, we are not
But
implementing it, but we are just using it.
yeah, that is fine, right? That is the ideal scenario, right? Suppose where you can use this DQ functionality, right? That means where you need to access in this order only, fast in, fast out. Once you process, then you want to remove that item. Then in that case, you need to use this, say, generic queue collection. So this is not the generic, but in that case, you need to use the generic queue, not this non-generic queue, right? So there is a difference between generic and non-generic, and I never personally feel good to use this queue. I never feel that much great to use this non-generic collection classes, because they are giving you very bad performance, right? So why we are discussing? Because this is required, right? Once you understand this, once you understand the problem, then you can understand the solution, right? If you are not understanding the problem, then you cannot understand the solution. The solution to this is, so here we are using a queue, right? And the solution to this is a queue of T, right? Suppose I'm creating queue of string, right? So then you need to write like this, right? Queue of a string. So this is the generic collection. Collections dot, you need to implement the generic namespace, right? So in this case, you can see as soon as I make this string as generic, you can see this is giving me compilation error. This is giving me compilation error. This is giving me compilation error. Why? Because I'm making this queue as a string, right? That means this queue is going to operate on string data type. If you are passing any other value other than string, then it is going to return me some kind of a error. And in this case, the boxing and unboxing is not going to be happen, right? Boxing and unboxing is not going to be happen, because this is going to be work on the appropriate data type. String means it is going to store the data in the string format only. But if you are using this queue, right, and if you are removing this one, then in this case, right, this is going to why I'm getting this error. Can anybody tell me why I'm getting this error?
Using system collection generic.
Exactly. because this queue collection class belongs to System.Collections namespace, not to generic namespace. So in this case, you just need to use that namespace. That is what I always mentioned, right? While I'm creating the instance, if you remember, always I put the first point as include the namespace, right? Include the namespace, right? Guys, take a break for 10 minutes, then we will come back and we will discuss the rest, right? That will not take more time. That is fine. If you are taking a break for 10 minutes.
Yes, sir.
Okay.
Okay.
Okay, fine.